the mysterious visitor racing through our solar system. Something extraordinary is happening in our cosmic neighborhood right now. An enigmatic traveler has entered our solar system, and with each passing week, it's revealing characteristics that challenge our understanding of what's possible. This visitor, known as 3I Atlas, was detected in early July 2025 by a sophisticated monitoring system designed to track potentially hazardous space objects. Since that moment, observatories worldwide have scrambled to capture every detail about this puzzling entity, generating heated debates and unprecedented scientific interest. But what makes 3I Atlas so captivating? And more importantly, what have we actually discovered versus what remains speculation? An unprecedented speed. 3I Atlas is the third confirmed interstellar object ever detected passing through our solar system. The previous two visitors appeared in 2017 and 2019, giving scientists valuable baseline data for comparison. However, 3I Atlas immediately distinguished itself with shocking velocity, racing through space at approximately 58 kilometers per second. That's over 200,000 kilometers per hour, making it significantly faster than its predecessors. Even more astonishing, preliminary analysis suggests 3I Atlas may be ancient beyond imagination, potentially between 3 and 11 billion years old. To put that in perspective, our entire solar system is roughly 4.6 billion years old. What elite telescopes have revealed. The world's most advanced observation platforms have redirected their precious time towards studying 3I Atlas, and their findings have been nothing short of remarkable. One of humanity's premier space telescopes captured detailed imagery when 3I Atlas was approximately 446 million kilometers from Earth. These observations revealed something unexpected about its size. Initial estimates suggested a massive body, but once researchers accounted for the surrounding dust and gas cloud, they realized the solid core measured far smaller than originally believed, somewhere between 440 meters and 5.6 kilometers in diameter. The streaking stars visible in the background imagery provide a visceral sense of 3I Atlas's incredible velocity as it tears through our cosmic backyard. A chemical signature unlike anything expected. Advanced spectroscopic analysis has unveiled a truly bizarre chemical composition for 3I Atlas. Observations revealed unusual outgassing patterns, with carbon monoxide and carbon dioxide sublimating more actively than water, at least during the initial observation period. But here's where things get strange. Researchers detected dust emanating toward the sun, not just away from it as normally expected. This counterintuitive behavior suggests the dust grains are fragmenting as they move from the nucleus, with gas production potentially launching particles in unexpected directions. Even more intriguing, 3I Atlas showed signs of activity at an extraordinary distance, potentially up to 6 astronomical units from the sun. That's near the outer limits where typical comets begin releasing material, suggesting this visitor might be ejecting exotic, hypervolatile substances like nitrogen or hydrogen. The brightness anomaly that shocked researchers. Continuous monitoring data from May through early June revealed something that defied expectations entirely. Scientists calculated that as 3I Atlas approached, its brightness should increase by a specific, predictable factor based purely on its changing distance from the sun. The expected increase was modest, about 1.5 times brighter. Instead, it became 5 times brighter. Multiple independent observatories confirmed this shocking surge in luminosity. 3I Atlas was radiating far more energy than any natural process could easily explain, suggesting intense activity that had potentially been ongoing for an extended period. Physical mysteries deepen. Attempts to determine 3I Atlas's rotation period produced puzzling results. The reflected light pattern appeared remarkably uniform, almost unnaturally so, making it extremely difficult to detect the periodic variations that would reveal how the object spins. Some signals suggested rotation periods of either 29 or 16 hours, though the data remained frustratingly noisy. Ground-based observations eventually supported the 16-hour period, but the unusually flat light curve continues to perplex researchers. A growing tail and toxic emissions. By late August, multi-wavelength imaging captured not just the surrounding dust cloud, but an actual tail structure extending into space. This tail measured significantly longer than in previous observations, providing concrete evidence that 3I Atlas's activity was intensifying as it approached the Sun. Spectroscopic analysis detected emission features indicating the release of cyanide molecules, approximately 800 sextillion molecules per second. While this might sound alarming, it actually places 3I Atlas on the lower end of typical values for similar objects. However, the chemical ratio analysis revealed something unprecedented. 3I Atlas is extraordinarily depleted in longer-chain carbon molecules. This depletion pattern could indicate formation conditions radically different from anything in our solar system. The polarization signature that changes everything. Recent polarimetric observations, studying how 3I Atlas polarizes light, uncovered its most anomalous characteristic yet. Researchers discovered an exceptionally deep and narrow negative polarization branch in the reflected light. This specific pattern has never been observed before in any asteroid, comet, or small body ever studied in our solar system. Even the previous interstellar visitor from 2019 showed completely different polarization behavior. This unique light-scattering signature potentially places 3I Atlas in an entirely unknown class of planetary bodies. An unexpected color change. Amateur astronomers photographing the night sky during a lunar eclipse in early September noticed something stunning. 3I Atlas had developed a distinct green coloration. Objects in our solar system can appear green when releasing diatomic carbon that fluoresces under solar radiation. But here's the problem. 3I Atlas was recently confirmed to be highly carbon depleted. It shouldn't have sufficient carbon to produce this effect. This contradiction suggests either rapidly changing chemical activity or physical processes we don't yet understand. The wow signal moment. And now we reach the most controversial development. One that has divided the scientific community and captured public imagination. A prominent researcher began circulating papers suggesting 3I Atlas might be too large to occur naturally based on current models of interstellar object frequency. The argument, given the amount of material in interstellar space, something this size entering our system should be extraordinarily rare, perhaps impossibly so. The scientists then took the extraordinary step of publishing a paper titled with a question about whether 3I Atlas could be artificial technology, invoking concepts like the dark forest theory and analyzing whether the trajectory could indicate intentional maneuvering. However, multiple problems emerged with this hypothesis. The size estimates being used were outdated, continuing to reference the 10-kilometer measurements even after refined observations reduced that figure to 5.6 kilometers maximum. The trajectory analysis was rebutted by other researchers who demonstrated the path could be explained entirely through natural gravitational dynamics without requiring any engineered acceleration. The lesson here illustrates the danger of rushing to extraordinary conclusions before data has been properly verified and peer-reviewed, especially for newly discovered objects where our understanding evolves rapidly. What happens next? 3I Atlas will reach its closest approach to the Sun on October 30th at approximately 1.4 astronomical units, sadly too close to observe during that critical period. However, it will re-emerge in early December, allowing for renewed intensive study. Critical questions remain unanswered. How will 3I Atlas's activity change at closest approach? Could it fragment under thermal stress? Can we trace its origin point? And perhaps most tantalizingly, what does its unique polarization signature really mean? The race is on to solve these mysteries before this ancient traveler disappears back into the cosmic darkness, potentially not to be seen again for millions of years. If you found 3I Atlas as fascinating as I do, hit that subscribe button and turn on notifications so you don't miss what happens when it reemerges in December. What do you think is really going on with this object? Natural phenomenon or something more? Drop your theories in the comments below. I read every single one. And if you're hungry for more space mysteries, check out the videos on screen now. There's a whole universe of enigmas waiting to be explored. Thanks for watching, and I'll see you in the next one.